Octopuses are among the most unusual creatures on the planet, and their physiology differs greatly from what we're used to. One of the most fascinating facts about them is that they have not just one but 3 hearts. 2 of these are called branchial hearts. They are responsible for pumping blood through the gills, where it becomes oxygenated. The 3rd heart, known as the systemic heart, then circulates the oxygen-rich blood throughout the rest of the body. This system may seem complex, but it is perfectly suited for life in the ocean, where efficient oxygen uptake is crucial. Interestingly, the function of these hearts is closely tied to the octopus's lifestyle. When an octopus swims actively, its systemic heart can temporarily stop beating. This is one reason why octopuses prefer crawling along the ocean floor using their tentacles rather than swimming long distances. This behavior helps conserve energy and keeps their body functioning more steadily. Their blood is just as remarkable. Unlike human blood, which is red due to iron-based hemoglobin, octopus blood is blue. This is because they use a different oxygen-carrying protein called hemocyanin. Instead of iron, hemocyanin contains copper, which gives the blood its distinctive blue color. Hemocyanin has its advantages. It is more efficient than hemoglobin in cold water and in environments with low oxygen levels, conditions in which octopuses often live. This allows them to survive in places where many other marine animals would struggle. However, this system also has its drawbacks. Hemocyanin becomes less effective at transporting oxygen in warmer temperatures, making octopuses particularly sensitive to environmental changes. In addition, octopuses have a closed circulatory system, which is quite rare among invertebrates. This means that their blood flows entirely within vessels rather than directly bathing the organs as it does in many other marine animals. Such a system allows for more precise and efficient oxygen transport, which is especially important for an active and intelligent predator. All of these features, 3 hearts, blue blood, and an advanced circulatory system make octopuses true biological engineering marvels. Their bodies are finely adapted to life in the challenging conditions of the ocean, with every detail contributing to their survival. That's why octopuses are not only unusual in appearance, but are also considered some of the most intelligent and evolutionarily advanced invertebrates on Earth. The idea of an immortal jellyfish sounds like pure fantasy, but it is based on a real biological phenomenon. The species most often associated with this concept is Turritopsis dohrnii, a tiny marine organism found in oceans around the world. What makes this jellyfish extraordinary is its ability to essentially reverse its life cycle, allowing it to avoid death under certain conditions. Like most jellyfish, Turritopsis dohrnii begins its life as a larva, eventually developing into a polyp, a stationary plant-like stage attached to a surface. From this polyp stage, it grows into a free-swimming adult known as a medusa. In typical jellyfish species, this is a one-way process. Once they reach adulthood, aging and death eventually follow. However, this species breaks that rule in a remarkable way.
When faced with environmental stress, physical damage, or even simple aging, Turritopsis dohrnii can transform its mature cells back into their earlier form through a process called transdifferentiation. This means that specialized cells change into different types of cells, effectively allowing the jellyfish to revert from its adult medusa stage back into a juvenile polyp stage. From there, it can grow again into a new adult, potentially repeating the cycle multiple times. Because of this ability, the jellyfish is often described as biologically immortal. In theory, it can bypass the normal process of aging indefinitely. However, this does not mean that individual jellyfish live forever in practice. They can still die from disease, predation, or environmental changes
In the wild, many never complete enough cycles to achieve anything close to immortality. The mechanism behind this process has attracted significant scientific interest. Researchers study Turritopsis dohrnii to better understand cellular reprogramming and regeneration. Insights from this jellyfish could potentially contribute to advances in medicine, particularly in areas like tissue repair, aging, and regenerative therapies. While we are far from applying such mechanisms to humans, the principles involved are highly valuable for biological research. Another fascinating aspect is how simple the organism itself is. Despite its extraordinary ability, it is only a few millimeters in size and lacks the complex organs found in higher animals. This shows that even relatively simple life forms can possess highly sophisticated biological mechanisms. It is also worth noting that the species has spread widely across the world's oceans, partly due to human activities such as shipping. This has made it easier for scientists to study, but it also raises ecological questions about how such species interact with local marine ecosystems. In the end, Turritopsis dohrnii challenges our basic understanding of life and aging. The idea that an organism can effectively reset its biological clock is both fascinating and slightly unsettling. It makes for an excellent conversation topic because it blurs the line between science and what once seemed impossible, showing just how surprising nature can be. The idea of an underwater waterfall sounds like something impossible, yet it is a real natural phenomenon that can be observed near the island of Mauritius in the Indian Ocean. At first glance, it appears as though massive amounts of water are plunging downward into the depths of the ocean, much like a waterfall on land. However, what is actually happening is even more fascinating and reveals the complexity of ocean geology. This striking visual effect is caused by a combination of underwater topography and the movement of sand and sediment. The ocean floor around Mauritius features a steep drop-off known as a submarine slope. Over time, sand and silt accumulate on the shallower parts of this slope. Due to ocean currents and gravity, these sediments are constantly being pulled downward into deeper waters. As the sand and silt cascade down the slope, they create patterns and streaks that resemble flowing water. When viewed from above, especially from airplanes or drones, this movement produces the illusion of a waterfall beneath the ocean's surface. The contrast between the lighter-colored sand and the darker blue of deeper water enhances this effect, making it look incredibly dramatic and almost surreal. It is important to understand that this is purely an optical illusion. There is no actual hole in the ocean or a place where water is falling into some hidden abyss. Instead, the ocean remains continuous, and the apparent motion is simply sediment shifting along the seabed. Still, the illusion is so convincing that it has captured the imagination of people around the world and become a popular subject in photographs and videos. The phenomenon is also linked to larger geological processes. The area around Mauritius sits on an underwater plateau that gradually gives way to much deeper ocean basins. The movement of sediment down these slopes plays a role in shaping the ocean floor over long periods of time. In this sense, the underwater waterfall is not just a visual curiosity, but also part of an ongoing natural process that influences marine landscapes. Another interesting aspect is how rare and unique this effect appears compared to other ocean features. While sediment flows occur in many parts of the world, few locations create such a clear and dramatic illusion. This makes the site near Mauritius especially famous among travelers and nature enthusiasts. In recent years, the location has gained popularity through social media, where aerial images of the phenomenon often go viral. Many viewers initially believe they are seeing something supernatural or even dangerous, but learning the scientific explanation makes it even more impressive. It shows how natural processes can create visuals that rival the most imaginative works of fiction. In the end, the underwater waterfall is a perfect example of how our perception can be tricked by nature. It reminds us that the ocean still holds many wonders, And even familiar elements like sand and water can combine in unexpected ways to create something truly extraordinary. Shark skin is one of the most fascinating and highly specialized surfaces in the animal kingdom, often surprising people who expect it to feel smooth. In reality, the skin of sharks is covered with tiny tooth-like structures known as dermal denticles, which give it a texture similar to sandpaper. These microscopic structures are made of the same material as teeth and are aligned in a way that reduces friction as the shark moves through water. Each dermal denticle has a ridged surface, and these ridges play a crucial role in hydrodynamics. As a shark swims, water flows over its body, and the denticles help channel that flow more efficiently. This reduces turbulence and drag, allowing the shark to move faster and with less effort. In simple terms, their skin is naturally designed to make swimming more efficient, giving them a significant advantage as predators. If you were to touch a shark, the sensation would depend on the direction of your hand. Moving your hand from head to tail would feel relatively smooth because you are following the direction of the denticles. However, moving your hand in the opposite direction from tail to head would feel rough and could even cause small cuts or abrasions. This is why shark skin has historically been used by humans as a natural abrasive material, similar to sandpaper. The efficiency of shark skin has inspired scientists and engineers for decades. Researchers have studied these structures in detail to replicate their properties in human technology. For example, special coatings based on shark skin patterns have been developed for ships and submarines to reduce drag and improve fuel efficiency. Similar designs have also been applied to competitive swimsuits, helping athletes move more smoothly through water. Interestingly, the benefits of dermal denticles go beyond just speed. They also help prevent the growth of algae, barnacles, and other organisms on the shark's body. The texture of the skin makes it difficult for these organisms to attach, effectively giving sharks a built-in anti-fouling system. This keeps their bodies clean and reduces additional drag that could slow them down. From an evolutionary perspective, this adaptation has been incredibly successful. Sharks have existed for over 400 million years, long before dinosaurs, and their skin has played a key role in their survival. The combination of strength, efficiency, and protection makes dermal denticles a remarkable example of natural engineering. Today, the study of shark skin continues to influence modern science and technology. By understanding how these tiny structures work, researchers are finding new ways to design more efficient and sustainable materials. What may seem like a simple biological feature is actually a complex and highly optimized system. In the end, shark skin is a perfect reminder that nature often solves problems in ways humans are still trying to understand and replicate. It turns a common assumption, smooth skin for fast movement, completely upside down, making it an excellent and memorable fact to share in conversation. The whale shark is the largest fish in the world, and its size alone is enough to impress anyone. These gentle giants can grow up to 12 meters long, and some individuals have been reported to reach even greater lengths. Despite their enormous size, which rivals that of a bus, whale sharks are completely harmless to humans. In fact, they are known for their calm and slow-moving nature, making encounters with them a popular attraction for divers and marine enthusiasts. What makes the whale shark even more fascinating is its diet. Unlike many large marine predators, it does not hunt big prey. Instead, it is a filter feeder, meaning it feeds on tiny organisms such as plankton, small fish, and microscopic plants and animals. To eat, the shark swims with its massive mouth open, taking in large amounts of water. It then filters out food using specialized structures in its gills, trapping the tiny organisms while expelling the water back out. This feeding method is similar to that of baleen whales, which is how the whale shark got its name. However, despite the similarity, whale sharks are fish, not mammals. They breathe through gills, lay eggs, and are cold-blooded, unlike whales. This distinction often surprises people and makes the fact even more interesting to share. Another remarkable feature of the whale shark is its unique pattern of spots and stripes. Each individual has a distinct pattern, much like a human fingerprint. Scientists use these patterns to identify and track individual sharks in the wild. This helps researchers study their migration routes, behavior, and population size, which is important for conservation efforts. Despite their size and strength, whale sharks are vulnerable creatures. They face threats from fishing, ship collisions, and environmental changes. In some parts of the world, they have been hunted for their meat, fins, and oil. As a result, their population has declined and they are now considered endangered. Efforts are being made globally to protect them, including marine reserves and regulations on fishing practices. Whale sharks are also known for their long migrations. They travel vast distances across oceans, often following the seasonal availability of plankton. These journeys can span thousands of kilometers and are still not fully understood by scientists. Tracking their movements has become easier with modern technology, but many mysteries about their behavior remain. Swimming alongside a whale shark is often described as a once-in-a-lifetime experience. Despite their immense size, they move gracefully and peacefully through the water, creating a sense of awe rather than fear. Their presence reminds us that not all large creatures in the ocean are dangerous. Some are gentle giants that play a crucial role in marine ecosystems. In the end, the whale shark challenges our assumptions about size and danger in the animal world. It shows that even the biggest creatures can be harmless and that the ocean is full of surprising and fascinating life forms. The idea that the ocean holds more historical artifacts than all the world's museums combined may sound exaggerated, but it is actually quite realistic. The seabed is home to millions of shipwrecks, lost cargo, and ancient objects that have accumulated over thousands of years. From early wooden vessels to modern ships, countless journeys have ended beneath the waves, leaving behind a vast and largely unexplored underwater archive of human history. One of the most famous examples is the wreck of the RMS Titanic, which sank in 1912 after hitting an iceberg in the North Atlantic Ocean. Discovered decades later, the site revealed thousands of artifacts, from personal belongings to parts of the ship itself. Yet the Titanic is just one of many. Experts estimate that there are over 3 million shipwrecks scattered across the world's oceans. These underwater sites can range from ancient trading vessels to warships lost in major conflicts. For example, many ships from the era of exploration, such as those used during the Age of Discovery, now lie on the ocean floor, carrying with them valuable clues about early navigation, trade routes, and cultural exchange. Similarly, ships lost during wars often contain weapons, equipment, and records that help historians better understand past conflicts. The ocean preserves these artifacts in unique ways. In some cases, cold and low oxygen environments slow down decay, allowing objects to remain intact for centuries. In other cases, however, saltwater pressure and marine life gradually break down materials, meaning that time is always working against preservation. This makes underwater archaeology both exciting and challenging. Exploring these submerged sites requires advanced technology. Scientists and researchers use remotely operated vehicles, deep-sea submersibles, and sonar mapping to locate and study wrecks. These tools allow them to reach depths that would be impossible for human divers, uncovering artifacts that have remained hidden for generations. Each discovery can provide new insights into history, sometimes even rewriting what we thought we knew. However, these underwater treasures are not just scientific resources, they also raise ethical and legal questions. Some shipwrecks are considered war graves, while others contain valuable cargo that attracts treasure hunters. This has led to international agreements aimed at protecting underwater cultural heritage and preventing looting or destruction. Despite all the progress in exploration, a large portion of the ocean floor remains unmapped. This means that many shipwrecks and artifacts are still waiting to be discovered. Some may hold priceless historical information, while others could contain lost treasures that have inspired legends for centuries. In the end, the ocean can be thought of as the largest museum on Earth, one that is mostly hidden from view. Unlike traditional museums, its exhibits are scattered across vast distances and often lie at extreme depths. This makes the idea even more fascinating. Beneath the surface of the sea lies a silent record of human history, preserved in darkness and mystery, waiting to be explored and understood.